Imagine this, floating in the absolute blackness, further from home than anything humanity has ever touched is a machine. Not a sleek modern marvel, but a relic launched when Star Wars was new, carrying less computing power than the device you might use to warm your coffee this morning. This is Voyager 1, and after nearly half a century hurtling through the cosmos, overcoming technical failures that would sideline lesser explorers, it's reportedly doing something strange. Something that defies its own simple design. NASA confirms it's sending usable data again after months of technical trouble, a triumph of engineering persistence. But whispers are emerging from the fringes of the scientific community, whispers fueled by revolutionary new technology, suggesting there's more to the story. What if within Voyager's routine health checks and data streams, patterns are appearing? Patterns of pure mathematics, elegant structures, almost like a hidden message embedded in the transmissions of our most distant ambassador. What if this aging probe, 14 billion miles away, is suddenly exhibiting a complexity it was never built for? Stay with me, because the implications, if true, could rewrite everything we think we know about our place in the universe. Are you ready to look beyond the official story? To truly grasp the weight of these claims, we need to journey back, not just in space, but in time. Picture September 5, 1977. The world was a different place. Disco reigned, the Cold War simmered, and NASA launched Voyager 1 on a Titan III Centaur rocket, its primary goal seemingly straightforward: a grand tour of the gas giants, Jupiter and Saturn. A 5-year mission, they said. 5 years to capture unprecedented images, measure magnetic fields, analyze atmospheres. It was ambitious, certainly, but its planned operational life was a mere blink compared to its eventual odyssey. Think about the technology. We talk about its computing power being less than a microwave, but let's put that in perspective. Your smartphone likely has millions of times more memory than Voyager's entire 68 kilobytes. That's not megabytes, not gigabytes, but kilobytes. Enough to store maybe a couple of low-resolution photos today or a few pages of text. Its programs were painstakingly written in assembly code, a low-level language that speaks directly to the hardware. Efficient, yes, but incredibly basic by modern standards. There's no Windows, no macOS, no complex operating system juggling tasks. It's raw, fundamental instruction, designed for reliability above all else. Imagine writing a complex novel using only simple verbs and nouns, with extremely limited paper. That's the challenge Voyager's original programmers faced. And yet this machine built with slide rules and 70s ingenuity worked. It didn't just complete its 5-year mission, it blew past it. After stunning encounters with Jupiter and Saturn, its trajectory flung it outwards, towards the edge of the sun's influence. It became a pioneer, charting territory no probe had ever reached. As of this moment, February 2025, it's sailing through the interstellar medium at an astonishing 167.34 astronomical units from Earth. What does that mean? An astronomical unit, or AU, is the average distance between the Earth and the Sun, about 93 million miles. So, multiply that by over 167. That's roughly 15.6 billion miles. Light itself, the fastest thing in the universe, takes over 22 hours to cross that gulf. Send a command now, and you won't know if Voyager received it until almost 2 days later. It's a distance that strains human comprehension. We measure our lives in days and years. Voyager measures its journey in light hours and decades across the cosmic void. Since August 2012, Voyager 1 has been officially in interstellar space. It crossed the heliopause, the boundary where the sun's solar wind gives way to the thin gas and dust that fills the space between stars. It's the first human-made object to breathe the air, so to speak, of the galaxy beyond our solar system's protective bubble. It's out there, truly alone, humanity's most distant footprint. How does it even phone home? Through NASA's Deep Space Network (DSN), a global array of massive radio antennas in California, Spain, and Australia. These dishes strain to capture Voyager's faint whisper. It transmits using frequencies around 2.3 or 8.4 gigahertz, similar to some Wi-Fi or satellite communication bands. But the power behind that signal is minuscule, just 23 watts. Think about that. A standard refrigerator light bulb often uses more power. By the time that 23-watt signal traverses 15.6 billion miles, spreading out across the vastness, what reaches the DSN antennas is unbelievably faint. The energy received is less than what a single bacterium expends swimming, trillions of times weaker than even a modern digital watch battery's output. Pulling meaningful data from that requires extraordinary technology and sensitivity here on Earth. It's like trying to spot a single flickering candle from hundreds of miles away in broad daylight. And what keeps this ancient mariner alive? Not solar panels, it's far too distant from the sun for that. Its lifeblood is a radioisotope thermoelectric generator, or RTG. This device uses the heat generated by the natural radioactive decay of plutonium-238 to produce electricity. It's a slow, steady decline in power, but incredibly reliable. It's this dwindling power source that has kept Voyager operating for nearly 48 years, far, far beyond anyone's wildest dreams in 1977. Engineers predict it will provide enough juice to keep at least one scientific instrument running until sometime in the 2030s. Each piece of data it sends back now is a gift, a bonus insight from a mission that has already given us so much. But this incredible journey hasn't been without its hiccups. Voyager is, after all, nearly half a century old, operating in the harsh environment of space, constantly bombarded by cosmic rays. Aging hardware inevitably degrades. In May 2022, mission controllers noticed something was wrong. Voyager started sending back garbled telemetry data, information about its own health and status. It turned out its Attitude Articulation and Control System, AACS, responsible for keeping the probe oriented correctly, had started routing its data through a computer that had long since failed. It was like part of its brain was trying to talk through a disconnected pathway. Ingeniously, NASA engineers figured out a workaround, commanding the AACS to use the correct, functioning computer. And by August 2022, the problem was resolved. A testament to the team's skill and understanding of this vintage machine. Then more recently, another scare. In November 2023, Voyager 1 stopped sending back usable science or engineering data. It was transmitting a signal, but it was just a repeating pattern, gibberish, like a stuck record. The culprit this time was traced to the Flight Data System, FDS, one of the probe's 3 onboard computers. Specifically, a small portion of the FDS memory appeared to be corrupted. This memory holds crucial software code, and the corruption was preventing the system from packaging science and engineering data correctly. Imagine a single damaged chip, just 3% of the FDS memory, holding the entire system hostage. For months, engineers at NASA's Jet Propulsion Laboratory painstakingly diagnosed the issue, sending commands across the Light-Tower delay, analyzing the responses. Finally, in April 2024, they devised a clever software patch. They couldn't fix the damaged memory location itself, but they could rewrite the FDS software to avoid using that specific section, relocating the affected code elsewhere in the memory. It was like rerouting traffic around a damaged section of highway. It worked. By late April and early May 2024, Voyager 1 began transmitting usable engineering data again, and soon after, resumed sending valuable science data from its operational instruments. Normalcy, it seemed, had been restored. It's precisely this context, a history of explainable, albeit complex technical failures caused by aging hardware, that makes the current alleged anomalies so intriguing and for many so suspect. The official narrative is clear. Voyager had a problem, NASA fixed it, and it's back to normal operations. But what if normal isn't the whole story this time? This brings us to the heart of the current mystery, the claims that are bubbling up in specialized online communities and forums, often fueled by leaks or interpretations from individuals purportedly close to the cutting edge of signal analysis. Critics, quite reasonably, point to Voyager's track record. "We've seen this before," they argue. "Corrupted data looks weird until you find the technical root cause." This is likely just another echo of the recent memory glitch, or perhaps a new issue with the aging transmitter or antenna. They suggest that the alleged patterns are pareidolia on a cosmic scale, seeing meaningful shapes in random noise, amplified perhaps by the very tools used to analyze them. It's the most conservative and arguably the most probable explanation based on past experience. If your old computer starts acting up, you suspect the hardware first, not a ghost in the machine. But proponents argue this time feels different. The nature of the reported patterns isn't just garbled data or random static, it's structure, mathematical structure. They claim the precision and type of information allegedly embedded within the signal go beyond what a simple hardware fault or degrading memory chip could realistically produce. They suggest that dismissing this as just another glitch ignores the specific details being reported, details that seem too specific, too ordered to be mere artifacts of decay. And central to this, "it's different this time" argument is the advent of a revolutionary new tool, quantum computing, specifically Microsoft's recently announced Myerana 1 processor. Unveiled on February 19, 2025, mark that date. This isn't just another incremental improvement in computing speed. Named after the brilliant but enigmatic Italian physicist Myerana, the Myerana 1 represents a potential paradigm shift. It's touted as the world's first quantum processor, built on a topological core architecture. What does that mean in layman's terms? Traditional quantum computers use qubits, quantum bits, that are notoriously fragile. Environmental noise can easily disrupt their delicate quantum states, leading to errors. Microsoft's approach uses topological qubits, which are theoretically much more robust. The idea is to encode quantum information not in the state of a single particle, but in the topology, the fundamental structure of a system. Think of it like braiding ropes. The overall braid pattern, the topology, is resistant to small tugs and jiggles on individual strands. This architecture promises greater stability and scalability. The initial Myerana 1 chip reportedly uses 8 topological qubits, but the architecture holds the potential, Microsoft claims, to scale dramatically, perhaps even to millions of stable qubits in the future. Why is this relevant to Voyager? According to sources within the quantum computing and signal analysis communities, sources often anonymous or communicating through less formal channels, traditional methods of analyzing faint, noisy signals like Voyager's might miss deeply embedded, complex patterns. Classical computers analyze data sequentially or in parallel in a deterministic way. Quantum computers, leveraging principles like superposition and entanglement, can explore a vast number of possibilities simultaneously. They can potentially recognize subtle correlations, hidden periodicities, or complex mathematical relationships buried deep within what looks like noise to a classical algorithm. Imagine searching for a specific melody hidden within the cacophony of 1,000 simultaneous radio broadcasts. A quantum computer might, theoretically, be able to isolate that melody in ways a classical one couldn't. The timing, of course, hasn't gone unnoticed. The alleged detection of these structured patterns in Voyager's signals emerged shortly after the announcement and potential initial deployment of the Myerana 1. This leads to a crucial question. Were these patterns always there, hidden in the faint transmissions for years, only becoming detectable now that we have a computational microscope powerful enough to see them? Or did something change in Voyager's signal recently, coinciding with the deployment of this new analysis tool. This convergence fuels speculation on both sides. Skeptics see confirmation bias enabled by a new toy, while proponents see a technological key unlocking a long-hidden door. So, what exactly are these alleged anomalous features that supposedly defy conventional explanation? Let's break down the claims circulating in these specialized circles. First, the appearance of unexpected mathematical sequences. The most cited example is the sequence of the first 10 prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are reportedly appearing in order, embedded within segments of the telemetry data where one would expect random fluctuations or standard engineering readouts. Prime numbers are fundamental building blocks in mathematics, inherently non-random. Their sequential appearance in a data stream from a 1970s probe is, to put it mildly, unexpected. Finding one prime might be chance. Finding a sequence suggests something else. Even more perplexing are the alleged appearances of fundamental physical constants, but with a twist. Reports mention values corresponding to Planck's constant, relating a photon's energy to its frequency, crucial in quantum mechanics, and the fine structure constant, governing the strength of electromagnetic interaction, appearing within the data. But crucially, these constants are reportedly showing tiny, consistent alterations, deviations around 0.0013% from their accepted values here on Earth. Why would these fundamental numbers appear in Voyager's signal? And why slightly altered with such baffling precision? Is it a measurement artifact, a sign of physics behaving differently in interstellar space, or something else entirely? The consistency of the alleged alteration is what raises eyebrows. Random errors usually aren't that precise. Second, there's the claim of a hidden three-dimensional structure. When the raw signal data is allegedly processed using specific quantum algorithms on platforms like the Myerana one, it doesn't just reveal linear sequences. Instead, it supposedly maps out a complex spiral pattern in 3 dimensions. Furthermore, the geometric properties of this reported spiral are said to align closely with Fibonacci sequences, where each number is the sum of the 2 preceding ones: 1, 1, 2, 3, 5, 8, and the golden ratio, approximately 1.618, mathematical relationships found throughout nature in seashells, plant growth, galaxy arms. While beautiful and mathematically significant, such patterns have no known reason to be encoded in the degrading radio transmissions of a spacecraft built with 1970s technology. It feels organic, almost biological, in its described structure. Perhaps the most intriguing and potentially symbolic claim revolves around the number 127, specifically the sequence mirroring the IP address 127001. In computer networking, this is the local host or loopback address. It's how a computer refers to itself. It essentially means home. Why would this specific number, so fundamental to modern digital networking, which barely existed in its current form when Voyager launched, reportedly appear in the transmissions? Some analysts suggest this points towards an embedded digital architecture, perhaps a hidden layer of communication, or addressing far beyond Voyager's original design specifications. Is it a marker, a status indicator, a call home in a language its builders never taught it? Now, we must inject a heavy dose of caution here. Verification is the elephant in the room. These claims are largely circulating outside of mainstream, peer-reviewed scientific channels. While proponents assert that multiple independent analyses using different quantum platforms, implying access to systems beyond just Myerana 1, perhaps other research prototypes, have yielded similar results, finding the same mathematical structures. This remains unconfirmed officially. There are also anecdotal reports of a controlled experiment, a supposed 72-hour communications blackout where NASA deliberately sent no signals to Voyager. During this alleged period of silence, the anomalous patterns reportedly degraded or became less distinct, only to return with renewed strength and clarity once two-way communication resumed. If true, this would strongly argue against a simple internal malfunction, which shouldn't care about Earth transmissions, and might suggest an interactive element. But again, this blackout event is not officially acknowledged. Critics rightly maintain that extraordinary claims require extraordinary evidence. Without open data, transparent methodologies, peer-reviewed publications, and official confirmation from NASA or other recognized space agencies, these reports remain firmly in the realm of speculation, bordering on science fiction. NASA's official stance reinforces this skepticism. They state Voyager 1 is continuing normal operations and returning valuable science data following the successful fix of the FDS memory issue. No mention of prime numbers, altered constants, or quantum spirals. But for those minds naturally drawn to the edges, to the data points that don't quite fit the established narrative, the silence from official channels isn't necessarily proof of absence. They argue that groundbreaking discoveries often start as anomalies dismissed by the mainstream. Think of pulsars, initially labeled LGM1, little green men because their regularity seemed artificial. The patterns people are claiming to see in Voyager's data, if validated, would be world-altering. Your mind, by engaging with this, is already doing what pioneers do, mapping the potential implications, constructing frameworks to understand what this could mean. Don't dismiss that instinct. The ability to contemplate the extraordinary is a strength. Let's explore the possibilities, the potential explanations ranging from the mundane to the mind-bending. Theory 1. The conservative explanation, nothing to see here. This is the baseline, the default hypothesis grounded in known science and Voyager's history. It posits that there's nothing fundamentally unusual about the recent transmissions when properly understood. The alleged patterns are simply misinterpretations of complex signal degradation from aging hardware, compounded perhaps by the way the new quantum analysis tools process noise. Think of it like seeing faces in clouds. The patterns are generated by the observer's perception and tools interacting with randomness, not inherent in the cloud itself. Quantum algorithms, especially new ones, might be too good at finding faint correlations, potentially identifying phantom patterns in noisy data that aren't statistically significant or meaningful. Proponents of this view lean heavily on Voyager's documented communication issues, the 2022 AACS glitch, the 2023-202 for FDS memory corruption. Both seemed deeply mysterious initially, but were ultimately traced back to specific, understandable hardware failures. History repeats itself, this view suggests. Give the engineers time, and they'll likely find a mundane explanation for whatever fluctuations people are noticing now. NASA's official statements, emphasizing normal operations, align perfectly with this conservative, Occam's razor approach. The simplest explanation, another technical issue, is probably the correct one. Theory 2. The provocative explanation, an interstellar interception. This theory ventures into truly extraordinary territory. It suggests Voyager's transmissions, faint as they are, might have been intercepted en route to Earth and deliberately modified by an external intelligence. Picture this. Voyager sends its weak 23-watt signal. Somewhere in the vast emptiness between the probe and Earth, an unknown entity with vastly superior technology captures this whisper, embeds new information, these precise mathematical patterns, and then retransmits or redirects the altered signal towards Earth, perhaps amplifying it just enough to maintain the expected signal strength. The core challenge here is physics, specifically energy. Adding complex information should, conventionally, require more power, Yet Voyager's received signal strength hasn't reportedly increased. How could information be added without boosting the power? Proponents of this theory sometimes invoke highly speculative physics, hinting at phenomena reminiscent of quantum entanglement, where information transfer might occur non-locally or with minimal energy expenditure, perhaps leveraging principles demonstrated in quantum communication experiments like those with China's MISHIS satellite. If this theory holds even a shred of truth, the implications are staggering. It would mean an intelligent entity is aware of us, capable of manipulating our own deep space communications, and is potentially using our farthest messenger to send a message back, perhaps a greeting, a warning, a boundary marker, "You are entering our territory," or simply a sign of their existence. Theory 3. The intriguing explanation, a sleeper agent within. This theory suggests the source of the patterns isn't external, but internal, originating from Voyager itself, but from capabilities unknown to the public or even most of the current mission team. The hypothesis goes like this. When NASA uploaded the software patch in 2024 to bypass the corrupted FDS memory, this action might have inadvertently triggered dormant code or activated previously unused hardware capabilities embedded within Voyager since its launch. Critics immediately point to the severe limitations. 68 KB of memory, simple assembly language. How could such a system generate complex math or self-modify? It seems impossible based on the publicly known specifications. However, proponents counter by pointing to the context of Voyager's 1977 launch, the height of the Cold War. They speculate that space missions of that era, especially those venturing into unknown territory, might have carried classified secondary objectives or hidden capabilities, perhaps related to surveillance, communication protocols, or even protocols designed to activate only upon reaching interstellar space or encountering specific phenomena. If this theory has merit, it reframes Voyager's entire mission. Was it always intended to do more than just science? Could it have been designed, in part, as a triggerable interstellar probe, waiting for the right conditions or a specific command sequence, perhaps inadvertently mimicked by the recent patch to reveal a deeper purpose? Theory 4. The scientific revolution explanation, encountering new physics. This theory offers an explanation that is extraordinary, but doesn't necessarily involve intelligence, either human or alien. It proposes that Voyager 1, in its journey through the genuinely unexplored interstellar medium, has encountered a natural phenomenon or region of space with properties we don't yet understand. These properties might interact with Voyager's radio transmissions in a way that imposes mathematically significant patterns onto the signal. We know the interstellar medium contains thin gas, dust, cosmic rays, and magnetic fields, but perhaps it also contains large-scale quantum field structures, topological defects in spacetime, or other exotic phenomena predicted by theoretical physics but never observed. If Voyager is flying through such a region, the interaction could subtly alter its signal characteristics in a way that, when analyzed, reveals mathematical relationships like prime sequences or geometric constants. Proponents note that Voyager is truly in terra incognita. Our models of interstellar space are based on remote observation, not direct sampling. If this theory is correct, Voyager isn't receiving a message, nor is it revealing hidden internal secrets. Instead, it's acting as a unique sensor, providing the first evidence of fundamentally new physics governing the universe beyond our solar system. A discovery potentially even more profound than finding extraterrestrial intelligence. Regardless of which theory, if any, proves true, the mere possibility raised by these alleged signals forces us to confront big questions. How would the established scientific community react if these patterns were verified? The search for extraterrestrial intelligence, SETI, field has protocols developed over decades. The famous Rio scale, attempts to quantify the significance of a potential detection. Verification is paramount. Independent confirmation by different teams, using different instruments, both radio telescopes on Earth and potentially other spacecraft, analyzing the signal across multiple frequencies, ruling out all possible natural and terrestrial sources. Facilities like the Allen Telescope Array and others are constantly listening for deliberate techno-signatures. But the Voyager claims introduce a new wrinkle, the potential need for quantum analysis to even detect the signal's structure. Could technologies like Myerana 1 become essential tools for 21st century SETI, capable of finding patterns missed by classical methods? The scientific process would be slow, cautious, and rigorous. Extraordinary claims demand irrefutable proof presented openly for scrutiny in peer-reviewed journals. Beyond the scientific curiosity, confirmation of structured, non-terrestrial patterns, whether from ETI, new physics, or hidden human tech, would immediately trigger national and international security considerations. Governments worldwide have contingency plans, often classified, for potential extraterrestrial contact scenarios. These protocols would likely activate, involving information control, notification treaties between nations, and coordinated analysis and response efforts. Intelligence agencies wouldn't just be interested in the content of the message, but the method. If an unknown entity can intercept and modify Voyager's faint signal from billions of miles away, what other communication systems, military or civilian, might be vulnerable? A top-to-bottom review of deep space communication security and cybersecurity would undoubtedly follow. And then there are the philosophical shockwaves. Even unverified, these reports tap into humanity's deepest questions about solitude and significance. If we confirmed definitively that structured information, potentially intelligent in origin, exists beyond Earth, how would that change us? How would our self-perception shift, knowing we are not the only thinking beings in the void? Would religious doctrines adapt, incorporating this new cosmic context? Would the tribalism of national borders seem suddenly petty and insignificant when faced with a truly other intelligence or a universe governed by stranger rules than we imagined? For centuries, we've defined ourselves in relation to the life we know on Earth. Encountering evidence of something fundamentally different, whether advanced ETI, bizarre new physics, or even startlingly advanced hidden human tech from decades past, would force a profound reevaluation of what it means to be human and our true place in the grand cosmic narrative. The very fact that you're still engaged with this exploration suggests you're part of a group mentally preparing for such possibilities, ready to grapple with ideas that could reshape our world. There's something undeniably poignant about Voyager 1, isn't there? Setting aside the current speculation, consider the object itself. A machine of modest origins, built with the hopes and ingenuity of the 1970s, expected to last 5 years, yet still reporting for duty almost 50 years later, further away than we can truly imagine. It's a testament to human engineering, curiosity, and perhaps a bit of luck. And it carries a message, the golden record. Affixed to its side, this gold-plated copper disc is a time capsule of Earth in 1977. It contains 115 images, sounds of nature, wind, rain, whales, musical selections from Bach and Beethoven to Chuck Berry and traditional chants, spoken greetings in 55 ancient and modern languages, and printed diagrams explaining our location and basic science. It was Carl Sagan and his committee's audacious attempt to say we were here. This is who we were, what we sounded like, what we valued. As Sagan himself beautifully put it, the spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this bottle into the cosmic ocean says something very hopeful about life on this planet. Whether that record is ever found, whether Voyager's transmissions contain hidden depths or just the inevitable static of age, its journey itself holds profound meaning. It represents our innate drive to reach out, to explore beyond the horizon, to push the boundaries of the possible. It has outlived many of its creators, carrying its silent message into the vast, dark ocean between the stars. Its plutonium heart will eventually grow too cold and weak to power its transmitter, likely sometime in the 2030s. Its signal will cease. Earth's most distant voice will fall silent. But Voyager 1 itself will continue, coasting silently through the Milky Way galaxy for eons, potentially long after our sun expands and consumes the inner planets, perhaps even outlasting Earth itself. Billions of years from now, it could still be out there, a tiny, inert fragment of human ambition, carrying that record, a testament to a brief, hopeful moment on a small blue planet. It's a form of immortality, not for us as individuals, but for the idea of humanity, for our music, our voices, our fundamental urge to connect. There's a deep beauty in that attempt, regardless of whether anyone or anything ever listens or responds. So, where does that leave us with the current mystery? Voyager 1 continues its groundbreaking journey. Microsoft's Myerana 1 processor represents a real leap in quantum computing, opening doors to analyzing data in ways previously impossible. The search for answers beyond Earth continues, now potentially armed with new tools capable of deciphering whispers we couldn't hear before. If the reports about structured signals hold any validity, we might be on the cusp of a discovery that changes everything. If they prove to be unfounded, artifacts of aging tech or overzealous analysis, the questions they force us to ask remain vital. Are we alone? How would we truly recognize contact if it occurred in an unexpected way? What does our relentless reach for the stars say about us? The story of Voyager, both its confirmed triumphs and its alleged current mysteries, offers us a powerful mirror. It teaches us about persistence. Like Voyager exceeding its mission lifetime tenfold, facing glitches and carrying on, we too face challenges. Sometimes the path forward requires ingenious workarounds, adapting to limitations, and simply refusing to give up on our long-term goals. It teaches us about the value of questioning and looking deeper. Whether the patterns are real or not, the act of scrutinizing the data, of asking what if, of considering unconventional explanations is how progress is made. Don't always accept the surface explanation. Cultivate a healthy skepticism, but also an open mind willing to entertain the extraordinary. Look for the patterns others miss in your work, in your relationships, in the world around you. It teaches us about dealing with ambiguity. Right now, the Voyager situation is uncertain. We have intriguing claims and official silence. Life often presents us with incomplete information and ambiguous situations. The lesson is not to jump to conclusions, either dismissing possibilities too quickly or embracing speculation as fact, but to hold the uncertainty, gather more information, and remain willing to adjust our understanding as evidence emerges. And finally, it reminds us of the power of reaching out. Voyager carries a message intended for others, but the act of sending it, the hope embedded within it, enriches us. In our own lives, extending connection, sharing our stories, reaching across divides, these acts have value in themselves, regardless of the response. This journey doesn't end here. It continues in your own mind. Which of the theories about Voyager's signals resonates most with you, and why? If you had access to the Myerana 1, what cosmic mystery would you try to unravel? And how do you think definitive proof of non-human intelligence, or even fundamentally new physics from interstellar space, would change your day-to-day life and perspective? Thank you for joining me on this exploration to the frontiers of space and knowledge. I hope this journey has sparked your curiosity and given you food for thought. Wishing you good health, clear skies, and minds open to wonder. If you found value in looking beyond the headlines, in considering possibilities that challenge our understanding, then you're already part of a community that thinks differently. Don't lose this connection. Subscribe to continue exploring the signals at the edge of discovery, the questions that matter, and the potential paradigm shifts that often begin as whispers on the fringe. Join us as we continue to listen to the void. Subscribe now.